Hello, welcome to CppChat. I have a bit of a programming note for you. It looks like Niall, who is trying to join us, has not succeeded yet. So we hope that he's going to join us sometime during the show. But if he doesn't, we'll have a great time. And if he does, it'll be even better. So I'm going to start the show now. And as you know, we start the show by reading the disclaimer, which in this case is that the information presented is intended solely for the purpose of providing general information about health-related matters. We do our best to ascertain that all information on this site is correct and up to date. However, we cannot guarantee that it is. The information provided here is for the educational, informational purposes only and designed primarily for the use by qualified physicians and other medical professionals. So, thank you very much. Let me introduce, we have two guests that are returning guests. Starting on what looks like my left. Jonathan, you want to introduce yourself?
Yeah. Hi, my name is Jonathan Müller. I'm a German computer science student. In my spare time, I blog and write C++ stuff. And yeah, and I'm running out of, I don't want to repeat the same introduction over and over again each time I'm here. So.
Well, you should make up a lie then. If you're a regular guest, you should probably say, I'm actually a British Secret Service agent and I'm licensed to kill, so don't screw with me. Anyway, we also have a guest that that has been on before, but not very often. So, Matt, you're going to have to tell us the truth because you haven't been on regular enough to lie yet.
How very boring. So, yeah, my name is Matt Godbolt. I'm a software engineer working for a trading company in Chicago. My main claim to fame, I suppose, is that my surname has become a noun or a verb. So as I run what I try and call Compiler Explorer, but everyone else calls Godbolt. I'm sort of getting used to that, I suppose, and and now I can't really. Yeah, go on. Sorry.
Is the Godbolt domain available?
Well, Godbolt.com is not, unfortunately. So I'm stuck with the .org. But it's cool. I wish I'd bought .com back in 1997 when I got the .org, but
of course. All right. So lots of things to talk about. Before we get into talking about outcome, which I think is probably going to be the interesting topic that we touch on today. Let's talk a little bit about what's happened, which is C++ Now. So you spoke at C++ Now, Jonathan. You want to talk about that experience?
It was great. I had a Saturday morning talk, and so the discussion wasn't as I would have expected. People just agreed to me, but they could just be tired and didn't want to start an obvious fight. So I don't know. But it was great.
Well, I wasn't there. If you know when I was there, I would have been telling you everything you were doing is wrong, right?
Yeah. Yeah, I ended 15 minutes early or so, but just because I anticipated more discussion and people just agreed to me. Either I'm good at convincing people or they were tired. Type-safe programming.
Okay.
It was about using the type system to prevent API misuse. The Scott Myers interface should be easy to use correctly and hard to use incorrectly.
Right, and that's what your library that you're working on is.
Yeah, type safe.
Right. Okay, but this was your first time at C++ Now?
Yeah.
Was this your first time in the US?
Yeah, it was my first time in the US. Okay.
I'm not sure that Colorado is representative of the US, but what was your experience like?
You really have cities that look like things I built in SimCity when I was 10. So.
Okay. I'm not sure what that means, but that's okay.
Yeah, the square streets and just Manhattan layout.
That's true. And in fact, you were in Colorado. The West very often is famous for having these really, really broad streets, and the reason is
I noticed that.
In the early days, if you were starting a town out and you didn't have broad streets, it meant you didn't have confidence that your city was going to grow big, because that was, And I remember there's this one little town in I think it's in Colorado. It's close to the Four Corners, and it's a little small town that didn't grow big, but it's a nice tourist trap because there's just it's beautiful and all this stuff. And you go there, And I kid you not, the streets are just, you could easily put 6, 8 lanes of traffic in there, and it's this little tiny town. There's never going to be 8 lanes of traffic, and it takes you, several minutes just to walk across the street because they were, oh no, we're going to be so big that we need to make these huge streets. So that was an indication of what kind of confidence you had in the future, right? But what about the conference? So it's not your first time being at a C++ conference. I think I met you at Meeting C++, right?
Yeah. Well, I kind of talked about that in the last CppChat episode.
Oh, that's right, sure.
It is a different feeling than Meeting C++. It's smaller. There are more famous people there than on Meeting C++. I enjoyed it there.
All right. Okay, that's good. So I want to announce stuff about CppCon. CppCon registration is open. And so if you're thinking about attending, please do. But more importantly, we are accepting calls for submission. And we need to get those in by June the 11th. And so that's a very narrow window. There's not many days left. But if you want to speak at CppCon, get that submission in. Is yours in?
You're talking to me?
Yeah. Sorry.
Oh, I'm not going to CppCon.
Oh, that's disappointing.
Yeah, well, it's the while this would be the only C++ conference where I wouldn't miss university, it's kind of a little bit. If I were to submit, I would have to prepare my talk during exams, and I don't think this would work out. Furthermore, I have no idea what to talk about. I already have to come up with downstream for Meeting C++ because the deadline also soon. And
okay, all right. Well, we will miss you. All right.
Yeah.
So I'll put you on the spot, Matt. Do you miss not having gone to C++ now?
I do. In fact, I was lamenting earlier to my wife about the fact that I haven't been to a conference like a C++ conference or anything like that for getting on for like, I guess 10 years now. I used to go all the time when I was making computer games. They'd send us off to, Microsoft sponsored conferences and things. But for some reason, I've fallen out of it. And having read the trip reports from the last couple of conferences from people like Jason Turner and other tweets and started watching all the videos, I'm thinking, I think I'm missing something. I should make it.
Yeah. Well,
so I will be coming to CppCon this year for certain.
Yeah. So that would be great. We're looking forward to seeing you there. So what else do I want to say? Oh, we're also having at CppCon, we will have classes which are on registration if you look. And we've got a lot of flavors you can do because you can do either before the conference, there's a 2-day class, or after the conference, there's 2-day class. And then we also did something different this time in case the 2-day is a problem. We actually have a 1-day class both before the conference and after the conference. So we're trying to accommodate people. And actually looking at the numbers, that's been kind of popular, is that a lot of people are taking advantage of the 1-day format. So I like to see that.
Is it like a 1-day either side, like bookending it, or is it just a single day?
Well, there's 2 separate 1-day classes. So you could do both, or you could do either one.
Got it.
Yeah. It is the same instructor. It's Nico Jositis, who wrote, of course, he co-wrote C++ templates, but he also wrote the standard library reference. And so he's a very knowledgeable guy. He's been working on the standard for a very long time. And so he's divided it up into 2 separate 1-day talks. So you could certainly do both as a single class if you wanted, or you could do either one. Right? That's the only 1-day we have. And then we have, I think, 5 2-day classes, both before and 5 after. And they're all different. So if you're interested in, there's got to be something there that's going to be interesting to you. So think about attending the classes as well. And then something that I was afraid we were going to have to cancel. In fact, I took it off the timeline, and that's the poster competition, because we didn't have anyone to run it. But now Bob Siegel is going to step up to run that. And so I'm very happy about that. So we are going to, we're going to be making some announcements about that.
Yeah, I was going to say, that sounds intriguing.
Yeah. Well, last year we only had, I think, 4 posters. So it's not an academic conference, so we don't get as many posters. But I think once people see what's possible, there's going to be more of that.
Maybe I'm being dumb here, but what do you mean by poster here? Do you mean like someone who's posting, or like a thing you put out and put on the wall?
It is a thing you put out and put on the wall.
All right. I see. Right. Okay.
So academic conferences do this
C++
a lot.
is awesome, you know, and then stick it on the wall, that kind of thing.
Well, no, it's results of some kind of study or information about some kind of library. So one person last year did have it was essentially a standard library proposal that he made a poster out of and said, this is what we'd like to see. So we'll follow up on that. As I say, we'll have some announcements about that. I also,
a new challenger enters.
You've no idea what the last 20 minutes has been like.
Niall, we are so excited to see you. Although at this point, you just look like is that a fox? We're not seeing your animation, but we can hear you, which is probably the most important thing.
Let me make because my picture was up when I joined, so and the camera light is on the laptop's turned on, so I don't know. All I can say is that Google Hangouts has seriously gone downhill from the last time I tried it. I've gone through 4 different web browsers, and I had to install deinstall my special Chrome edition just to put in Google Chrome. So anyway, as I say, it's been a fun 20 minutes.
All right. Well, I've already introduced the other fellows. You want to talk a little bit about what you do?
What do I do? Mostly unemployed at the minute. That's actually, I'm out of contract. So I suppose I occasionally turn up at C++ conferences and bore the tears off people. Right now, I am trying to get another one of my libraries into Boost, and that is turning out to be a fun occupation. I've spent the last 4 years being primary admin for Google Summer of Code at Boost, but it's my last summer. And other than that, not a lot, actually. I'm tired today, I have to say. The reviews are very taxing.
Yes. Jonathan just suggested that perhaps your camera doesn't have permission. Is that possible?
That's entirely possible, and I will go investigate options whilst we chat.
All right. So it was Jonathan said, hey, I want to be on the show this week because I want to talk about outcome. And it occurred to me, oh, we should get Niall on as well. But the thing is, Jonathan didn't say if he likes outcome or if he doesn't like outcome. So either he's here to praise you or to bury you, one of the two. But I suspect you've endured both in your career, so you're ready for either, right?
Yeah. All I can say is that the review basically is now turned into lots of other people rewriting the library for me, which of course is fine. So I would imagine that the presented form, although I don't want to speak obviously for the review manager, but I would imagine the presented form as it was submitted is probably not going to resemble at all what will actually be accepted, which is of course the whole point of a review. So
that's right. That's progress. That's progress. And I want to say that I appreciated your being on CppCast. I'm a big fan of CppCast, so I listened to it. And I really enjoyed your talk. I think you did a great job of giving people an idea about what the review process is like. And you kind of made it clear that there's maybe a couple of different kinds of libraries. You referred to it, I think you called it a fundamental library, as opposed to a more niche library. Is that fair?
Yeah, no, it's definitely the case. I mean, it used to be the case years ago that we had lots of fundamental libraries, and they've all gone on into the C++ 11 standard library, you know. So there used to be these really big, huge debates, but they've become less and less and less as the low-hanging fruit has got plucked, and more of it's got standardized. So we have now these sorts of, I mean, I've been very lucky to have tried getting 2 fundamental libraries into Boost, and both of them have turned into these 500+ email long debates. Yeah. So in that sense, I've been very lucky, or I'm a masochist. It's one or the other. I don't know which yet. By the way, I've discovered that the reason there's no video is apparently that Chrome has to be restarted after I've granted the camera permission. So at some point, I will kick myself out, close down Chrome, restart it, re-enter into this, and apparently I will appear.
Well, I have an announcement I want to make about next week's show. So now would be a good time you do that, and then I'll talk about this announcement, and then you can come back and join us with video, because that would be great.
Cool. You'll see how wrecked I look. See you soon.
All righty. Bye. Okay. So the announcement I want to make is about next week's show. We have Howard Hinnett has agreed to be on, and I want to. I don't want everybody to run off and read this right now, but here's a link to. I just pasted this in the chat room. A link to a blog post that I want Howard to comment on. In this blog post, the author, whose name I think is Thomas Guest, has basically said that we have partial sort in the standard library, but it's not the correct way to do a partial sort. There's a much better way to do it. This is a summary of what he's saying, which is to first call nth element and move all of the elements that you want to sort into the correct range, and then just do a full sort on the subrange. And he has done some timing tests to indicate that this is, in his timings, dramatically more efficient way of doing this. And since Howard has probably worked on, this is a question I need to ask him too. I think he's worked on more implementations of the standard library than anybody else, because he's only worked on 3, but there's not that many implementations. He worked on the MetroWorks implementation, and then he worked for a little while, not very long, on GCC, and then he started libc++. So he's worked on those 3 implementations. And he's, I think, the perfect guy to ask about why the standard library tends to be implemented using the algorithm that it uses for partial sort, and why does it not just use nth element followed by a full sort. So I'm really looking forward to that. And of course, having Howard on is great because he has an awful lot of insight. He was the chair of the library subcommittee for a lot of years. And as I said, he's worked on 3 different standard libraries. So he knows a lot. Yeah, Vinny says, Howard is coming. Yes. Howard will be here next week. So you don't want to miss out on next week's show. I don't do a lot of self-puffery, but I do want to give you the heads up because you want to do this. And you want to have read, do your homework. You want to have read this blog, which is a great blog to read. It's not very long, and it's a lot of fun to read. So be sure to read the blog. Don't do it right now. Do it after the show, but before next week's show.
It's just here. It's very cool.
Yeah.
Now I'm going to be distracted the whole way through this. Sorry.
We've already lost Matt as he's reading the blog.
Yeah.
So while we're waiting for Niall to reappear, do any of you want to have something you want to talk about?
I guess we were. My homework this morning was reading up on the Boost.Outcome stuff, and so I'm ready to talk about my interpretation of little bits of it at least. But
Okay.
presumably I will wait for Niall to come back in, assuming he can find his way back in. He's in some other circle of hell right now.
Yes.
Yeah.
Those little O's in Google are the little Google circles of hell.
That's right.
All right. So we should probably talk about something else. Is there anything else going on? Oh, so the other there's a call for submissions for Meeting C++, which is still open, but not much longer. Is that right? Jonathan, you said you applied.
Yeah,
for that,
it's open until the 1st of June, I think.
1st of June. Okay.
Which is, I don't know why he does it so early. I mean, on the one hand, you can procrastinate on preparing your talk all summer and autumn before the conference, but I don't know. It's just odd that it's earlier than CppCon.
Oh, it's not earlier than CppCon. CppCon is later than it. we would love to have had we had some problems getting it up, and so we've really squeezed our flow. It actually it doesn't seem like it should be that bad. Somebody submits, we decided we want to have it. Why is it? It's a lot of work. We get a lot of submissions. We don't have enough time really to pay as much attention to each individual submission as we like. We have to very, very quickly evaluate submissions and put together a program and then get it scheduled and get it online. And it's a very tight flow. And you have to do this far enough in advance that all the speakers that have been accepted know that they can make their travel arrangements. So we were late this year. Actually, I think that Meeting C++, Jens is on schedule. It's that we were late.
Okay.
So it makes sense. So was there a talk that you wanted to share from C++ Now that you attended? Did you attend Malte's talk? Malte Skaru? He was talking about the radix sort.
Oh, no, unfortunately, I have to moderate something else.
Okay.
During this.
Well, let's talk about that. You were a volunteer. Okay. How did that go?
It was fun. I can say that. It was fun to be a volunteer there. It wasn't too much work for those who are thinking about joining, so you can feasibly do that and don't have to do too much. It's okay. It's kind of when you're moderating the session, and you kind of have to ensure that the speaker is on time, and you kind of have this emotional problem too if the speaker doesn't have enough time left, which is kind of stressful. You know, there's someone who's giving a great talk, but he only has 10 minutes left, and you're always estimating, could he do this slides? He did the past 10 slides in 2 minutes, so maybe he could. So it's kind of, you're like giving the talk too.
You're
I think
emotionally helping him, right? You're giving him moral support.
Yeah. Yeah.
So I will say this, because this is submission season, if you will, and I put this on the CppCon website for people making submissions, but I really want to stress it. The biggest single feedback that we get at CppCon, and we have surveyed every single speaker and asked people, what did you think about this talk? And the single biggest problem that we see is that people are talking too fast and trying to cover too much material. And I am completely in touch with that. I understand exactly why that happens from the speaker side. You want to say so much. You want to make certain that what you're saying, you want to make sure it's worth it. One of the things that speakers have is they're afraid that what they're saying is something everybody already knows, right? So you try to pack in as much stuff as you can, and then you end up just covering it as quickly as you can to get it all covered, and it makes not as nice a presentation. And so, as difficult as it is, we're asking people, put what fits in an hour's time. And one of the problems that with CppCon is that it is only an hour slot, not an hour and a half, as C++ Now is. And that makes a pretty significant difference. I am completely torn about this. I pushed hard to do 90-minute talks at CppCon, but a lot of people on the planning committee said, 90-minute talks, that's really long. Hour talks are better. And now I think it may be too late to change it, because if we were to change that, what we would be doing is reducing the number of talks we can have. And that's tough to do, because we say no to so many people already. So, Niall, are you with us?
Well, now Hangout says that it refuses to use my camera because there's a problem with my camera hardware, so I give up.
Okay.
It's an Apple MacBook Pro, so camera definitely works. I use it every day to go and do Skype conversations and stuff. I think just Hangouts is bugged, personally.
Okay. So we won't be able to see the shadow under your eyes, the bags under your eyes, yeah. But that's okay, because we just want to hear your voice anyway. Anyway, we want to start talking about outcome. So before we launch into the pros and cons of outcome, the status of outcome, all these kinds of things, tell us a little bit about what outcome is trying to do and what it's about.
Oh dear. So fundamentally speaking, it lets you return either
I'm sorry. Let me go back one step. I think everybody knows this, but just in case. Outcome is a library that you've written and is submitted to Boost, and it has gone over the Boost review process, which is it completely finished, or is it close to finished, or where are we at with the review process?
No, they just extended it by another week
to
allow for further discussion.
All right,
so
now
there's
tell us,
only been 430 emails exchanged so far.
Okay, all right. So go ahead now and tell us what you're trying to accomplish with this library.
So yeah, I suppose anyone who's familiar with Rust to Swift will be familiar enough with the result type that comes back that lets you return either a T for some type for success, or an E for some error code type. So this has started down a long road of getting the similar things standardized into C++, which is what Vicenti's been leading out for expected. So that's the expected proposal. And we're thinking probably C++ 20, although he seems to have changed quite a bit out of the outcome review now. So I don't know if that'll push it back, but we'll see what happens next. So yeah, so outcome provides an expected implementation and also provides a series of refinements to expected that do similar but slightly different things in terms of semantics, and then thus begins the bike shedding. So everyone obviously has a different opinion of, firstly, what expected should be at all. So that would be the thing that's going before C++ standardization. One would have thought that the water had passed under the bridge by this point, but in fact it has not. And then on top of that, my refinements then, there are many factions with many opinions on the different varieties of what it should be. Now, what I would say is that I have been using these things in my own code, the formulation I proposed, for about 2 years, a year and a half, 2 years. And I know that my current design, whilst not optimal, it's certainly surprise-free, shall we say. So I've written a lot of code that works very, very well, with good balance of debugging and performance and a series of other things. But my opinion on the design is a minority view. So I suspect the library will be rejected, and I'll have to come back with a more popular, I suppose, reinterpretation, certainly as far as the defaults go. So that's currently where it's at. I mean, as much as it might sound to listeners or viewers very anodyne about a difference between a T or an E, you know, given that all the other languages have already implemented this, and you might all just say, well, isn't it just a stood variant? Yes, it is, but at the same time, it's not, because the reason why people get very, very worked up about this particular design is that it affects all your public APIs will now change or be different or so on. You've got to worry about naive programmers using it and accidentally shooting themselves in the foot. You've got to worry about experts coming along and getting very angry every time they use it because it just offends their ideological sense of purity. I know that this is all very funny sounding, but these are some of the many issues which come up. And of course, this has all been raging on at WG21 for some months, right, if not a year a bit. And Vicente, all I can say to you is that you are superhuman for managing to get it to go this far already, and still be very positive and can-do attitude about it. So congrats to you.
So it is. It's an implementation detail that's all over the interface, is what you're saying.
I think it's because it has so many knock-on consequences to anything that uses it in terms of all of the public APIs coming out of libraries, in terms of, I mean, it's something as potentially as head-wrecky as say string view, because anytime you move a string in and out, how string view is precisely designed will have lots of ramifications and knock-on effects and ripples that propagate out of that. So I can see that it's important to get it right. Equally, I like to echo sometimes what Bjarne often says, which is just ship it, and if it's broke, we'll fix it. But I appreciate that's not a popular view either in Boost or in ISO standards. So
certainly
people
not
like to get it
popular
right.
with me. Yes.
It's not popular with you either, no?
Well, I mean, if we don't get it right, of course we'll fix it, but we really, really want to get it right. Which touches on something. This is probably not the correct place to insert this, but I want to make certain I say this. I had several discussions at C++ Now with people who are on the standards committee and have kind of made a commitment to push harder on experience with libraries. I think, you know, it used to be that the way to get a library into the standard was to go through Boost. Now it's a lot easier to just, you know, skip the review process, put it out on GitHub, write up the documentation, and write a paper on it and submit it. And if I'm sitting in the standards committee and I see, oh, here's this paper based on the Boost library, and here's this paper based on a GitHub library, they look the same. They look like they're well thought out. They make sense. I read the papers. But the difference is one has thousands of users, and the other one has maybe a couple dozen users. And that difference is not obvious, but it's important. And so these people I was talking to at C++ Now are saying, you know, they told me, I'm pushing back. If I see a library proposal, the question I'm going to ask is how many users? And if the answer is not in the thousands, I'm going to say it's not ready. Now, it doesn't mean they have to go through Boost, but, you know, but they're going to push back on this because something happens with the review process and with actual users actually using it that you can't simulate by just having some really smart people, admittedly smart people, sitting in the standards committee, looking at the proposal and anticipating all the problems. Anyway, this was maybe not the right time to insert that, but I wanted to insert that somewhere. So
I definitely agree. It's been one of my big concerns that I've raised over the last few years is the proliferation of people skipping incubators like Boost and going straight to developing libraries by committee via the WG21. I'm not disparaging the 120, 150 people who go there, but put it this way, stood optional has a number of things I have serious problems with. It should never have gone into the standard in the way that it has at the minute. And it's too late now. It's shipped. There's code that's going to be written against it. And now we've got problems with expected precisely because it has to look to conform to optional. And I actually said, no, don't have it conform. Simply say optional was wrong. Let's do something better in expected. And, let that water go under the bridge,
I mean, I think there's a temptation on the part of the committee to say, well, yeah, Boost did it this way, but we're smarter than that. And it's like, well, you might be smarter, but you don't have thousands of users that have used what you're proposing. And that makes a difference. And anyway, enough of this. So the status is that the review has generated lots and lots of emails, lots of things that you're responding to. And according to CppCast, you weren't always as diplomatic in your responses as you might have liked to have been. But we've extended the review for a week. I shouldn't say we. The review manager has extended the review for a week. So people who are inspired by this episode can go to Boost, download the library, take a look at it, and make their comments, right?
Oh, sure. As long as the review or comments come back after somebody's actually read the documentation, I'm happy. It does irritate me when somebody has never read the documentation, never looked at the library, never looked at the source code, and yet will come in and absolutely slam it based on hearsay that they've read it or heard or read someone else's email, and that does get my goat. I try to be civil.
Okay, so that's the intent of the library. That's the current status. Now, I'm going to give this to Jonathan to tell us why you wanted to talk about outcome in the first place.
Well, first up, I like your library. I think it's great. I think I can also agree to some of your iterations of the result types you've implemented. But and I don't actually want to talk about those. I want to talk about the empty state you had in that types. So
the empty state is controversial, yes?
Yeah. So if I understand correctly, your expected had contained either a value, an error, or nothing.
Yeah, so that was one of the more controversial things, was the choice of a formal empty state. So it's not a hidden empty state like what stood variant in C++17 that occasionally can happen under certain circumstances. I chose instead to make empty a formal, completely valid state in its own right, but with special semantics, which are different from all the other possible states that could be. So specifically, it always throws an exception, no matter what, and it's a very specially tagged exception. And I still feel that is a very useful feature to have. But then you see, I'm thinking very much in terms of tribals here, rather than in terms of binary logic. And a lot of people don't like the idea of a three-way logic. It gets them upset. So anyway, I've agreed to drop the tribal. I've agreed to drop the empty state. The empty state is now not going to be on the default result and outcome types, and instead will be provided as an optional extension that you can opt into.
So you originally put the empty state in just to avoid the valueless by exception issue when you have the wrong move constructors and things like that, or was it just to... What's the use case?
So we actually implement we implement a never empty guarantee from move and assignment and copy throwing. So so in other words, your empty state never arises on its own magically. It only ever occurs if you actually ask for it, or if it happens to propagate down a logic chain where it's like it's an overriding thing. So if you combine it with empty, you'll get empty coming out. So the empties will appear and pop out of a logic chain to indicate something's gone wrong. So that was the notion behind it.
Okay, so that's good. I like that. I really hate the value list by exception state of variant, but it's necessary for the current design of variant and the current requirements of the type, but I disagree with that. I've talked about that before. But so when would I return an empty expected under what circumstances?
Well, don't forget, I haven't implemented any extension to expected with empty.
Oh,
because
okay, to an empty result or.
Yeah, so
Okay.
an empty result. So there's lots of cases. I've posted bits of code that I've written over the last few years where the empty state was used as an out-of-band communication. So the idea is that in your particular piece of code that you've written, you want to signal to the caller that something weird has happened, but not an error, and not success, but something else. So it's an out-of-band like you have in a socket. So that's one of the cases where I've been.
Sorry, that's a terrible example. The out of bound and sockets is like the most stupid and underused thing ever because of that.
I completely agree, and that is exactly right. But sometimes it makes for better code. And I'm one of the people who uses GoTo, by the way, in my code. I'm one of those. So I like GoTo. I think GoTo is the correct solution sometimes, rarely, for a particular use case. And people, I've had, I remember Chandler Kruth nearly falling off his chair when I actually argued in favor of GoTo in modern source code. And I said, no, GoTo really is better than alternatives in some certain circumstances. But I'm one of those. So that probably explains why I like out-of-band state.
So,
and by the way, it's a very minority position, and everybody disagrees with me.
No, I don't.
So what is this? What is this out of bound? I mean, are we talking about? It's not a runtime error. Instead, it's a logic error. It's a violation of contract, or what?
No, it's not a statically determined state. It's a runtime determined case. So the out of bound, you don't have to use it that way. The reason why one would tend to use it that way is because the empty state is treated very, very specially. So if you attempt to fetch, for example, an error from a valued result, you'll get back a null error code because there is no error here. So that doesn't throw an exception. If you try to fetch an error from a valued thing, sorry, the other way around. If you try to fetch a value from an errored object, then you'll get the error rethrown out as an exception. So it'll report that back out. But the empty gets its own special type, which kind of stands out in the debugger that indicates that something has gone wrong here. So when you're writing your code and you're debugging it, if you suddenly see, when you put a trap on all exceptions being thrown, if it pops up with a what is now named a bad outcome access, it didn't used to be named that, it's been renamed since the review feedback came in, then you know that there's a logic error in your code, and you immediately go, oh, that's not right, because an empty access should never ever occur in this code that I'm currently debugging. So you'll step through it. You can obviously put a trap on the particular type, and you'll find out where it's propagating out, and you go, oh, found the bug real quick, fix it, solve it, and that's happy. Some of the people on the Boost developers list wanted us to overload the error code by putting a special magic constant magic cookie constant into the error code to have the error code delineate the empty state or non-initialized state as it propagates through. And I really, really hate that design proposal, but it is quite popular. People feel that's a facility of error code, so why shouldn't we use it? And I'm of the view that no, the semantics which are implemented on the APIs which deal with error codes have a certain way of behaving, and if you start overloading things with magic cookie numbers, then you're going to have to add in a whole lot of if statements to test for the magic cookie numbers. And also, they don't cause semantics to behave differently. They don't have a weird execution path that pops out that stands out to the debugger, sorry, to the developer. So these are all where the discussion gets very involved. And you can see why there's so many different opinions. Most people think I'm wrong. Certainly, the majority would think I was wrong. There's also the decision of wide contracts versus narrow contracts on the observers. I'm one of the people who doesn't like reinterpret cast being sprinkled by the compiler magically in places that doesn't say the phrase reinterpret cast. I want to see that actually in my source code every time I'm doing that. That's me personally, but again, that would be a minority viewpoint. Majority seem to feel that sprinkling reinterpret cast all over the observers to these objects is perfectly fine. I disagree, but in the end, democracy is what it is. So it's being changed that there will be narrow contracts and everything. If you access value or error without checking the state beforehand, you get a reinterpret cast of the underlying variant storage. No checks.
Well, that's what undefined behavior is. I mean, that's.
Well, no, there's benign undefined behavior. There's undefined behavior because the standard chose not to define it, and then there is reinterpreting bits to be something completely different from what they were before, which is what I would call personally potential memory corruption. Is what I would personally call it.
No, I mean, if the standard hasn't defined it, then you have to assume it's memory corruption, right? That's what undefined behavior means. It's worst case. What is it that you really don't want to happen? That's what you have to assume happens. You can't just say, well, I know what the platform is, and even though the standard doesn't say what has happened, I can predict what will happen because I know what happens when the compiler writes code that does this. And this is just something that it's not necessarily supported, but I just know what it's. No, you don't. That's what's got us into some of the problems that we have. If it's not defined what it does, do not allow it to happen. You have to assume that's memory corruption.
Well, rather than get into that particular debate, I would say that the majority view is that the observers should just return a reinterpretation of bits underneath the bonnet, just as std optional does. So the argument is that if std optional does it, so should expected, so should outcome result, and all the others by default. And in other words, the idea is that you don't pay for what you don't use. So that's the argument there, that you shouldn't be paying for a state check before you reinterpret your bits. I personally would say that you're talking tens of CPU cycles at worst, at absolute worst here. But it is an opinion, and in the end, its majority have felt it. So that's the way the library will go.
Okay.
So you previously argued that they should check and then throw an exception at them?
I felt, given that these outcomes particular objects are mostly used for error handling, because they're mostly used for error handling, I think that they should default to a checking semantic, because it makes sense that if you are in a situation where you're dealing with either success or failure, that the checks of state are so minuscule in relative to the overhead of everything else that's going on in terms of unwinding things, in terms of dealing with results. I think it's an inconsequential overhead. But I can certainly see that some people would feel that the fastest possible code is the code that never does a check at all, and they would take, that opinion. So we'll give them what they want.
It's a shame you can't return a boost outcome to determine whether or not you got the outcome right, because throwing an exception seems to be counterintuitive to the whole point of the library in the first place, right?
Oh, sure. I originally had this notion, that if you could mangle up a symbol to call that would reflect the source code file name and the line number, right, that you could construct something like that, and you could try to link to it at that point. That way, then when you got a linker error, you could go back and actually see what's the source code number and the line number of where you could have thrown an exception. And that way, then you could track down every possible case that you could have thrown an exception, remove them from the code, and then your code would link. But unfortunately, compiler 2 sets are just not up to it yet. It's a really cool idea, but it's actually really, really hard to implement without doing really evil things. And of course, it only ever work under release with optimization builds only anyway. Mm-hmm. So that would be an unavoidable outcome. And you're kind of relying on the optimizer to really do a good job, which they don't always do, actually. Sometimes they spontaneously give up a bit too soon. For example, in GCC, try throwing something without a vtable, a type without a vtable, and watch the terrible, terrible code that gets output under optimization. No reason why. It's almost certainly a bug in the compiler for some reason.
Interesting. Matt, did you have other comments? You said you looked at the library, at the proposal.
Yeah, I mean, it was interesting to me because we've rolled our own. Nowhere near as oh, I'm muted, aren't I? Hang on, am I muted?
No,
or can you?
No, I'm
muted. Sorry, no. I just forgot. I was coughing earlier and I was muted, and I thought, oh god, here we go. But yeah, we rolled our own because of the same kind of feeling about the idea that exceptions in general weren't a great mechanism for propagating expected failures, but very often you want to return the objects that you know, in the common case, you want the std string of the read the whole file contents or whatever back out, and so we ended up rolling our own. So that it was interesting to see. I had no idea that there was an equivalent even coming down the standard or whatever. I knew about status code only because of doing like ASIO type stuff, which has a similar field to, or sorry, error code. But I didn't realize that there was an idea of coming a standard way to do this kind of thing. So that was why I was interested in the paper, just because it solves a problem that we have in a standardized way. But I have no real strong opinion about the behavior. I guess I would mildly fall in the unchecked category, if only just because CPU cycles are cheap, but it's nicer to not. In the same way that we have a choice of vectors, don't do range checking when we use the easy angle bracket thing. Maybe you disagree. Maybe there, in fact, Niall, what would you think? Was that a wrong default in your view, or not? Vector angle brackets versus vector.at number is what.
I know what you mean.
Right.
I'll tell you something. The whole design of std vector just really irritates me. I think that's also a serious design mistake.
Really?
Yeah.
Whoa. Go on, give us a quick TLDR of why you don't like it.
I just wouldn't design std vector the way it is in the standard library. So for me personally, I would have designed it much more around that so in other words, memory allocation or reallocation should never ever occur unless the programmer specifically says you are permitted to memory reallocate during this operation. I know they're pasting that on now in C++17 by adding in the try and place feature finally. So that's coming in a sort of roundabout way. But I would have actually started with the design on the basis that that should have been there from the very beginning. And I would have had error codes actually coming back out again because they're extremely lightweight. So std error code would be returned to indicate that we couldn't do this for some particular reason. Or for example, if something threw during the middle of or attempted to throw during the middle of a resizing operation. There's a long list of things that I would have done very differently with std vector. Now, when it comes to running off the end of bounds, I would say that it's interesting with std vector because the static analysis tooling and valgrind and address sanitizers, they've all become sufficiently good nowadays that I think you can actually leave off that kind of checking for bounds accesses on something like std vector. I actually would let it go. I actually don't think you should have any bounds checking on that because the static analysis tooling is there to support you. So in terms of that sense, it works out nicely. But for something like expected or variant stores, the tooling's just not there yet. I'm sure it will come.
So you can already, with the address sanitizers and things, areas of memory can be like poisoned from the user side. So it would seem pretty straightforward to put support in to say, look, this thing you're not allowed to look at, and allow the tooling to catch an uninitialized read from an area of memory that's been marked as like this isn't actually initialized. So I imagine it will come quickly, especially if it's standardized.
Yes. So in fact, actually, one of the things that's been stressed during the outcome review was there's built-in unreachable, which you can call to indicate that this pass should never ever happen. And some static analysis tooling will spot the fact that when a built-in unreachable would be called, it will choke at that particular point. And we can build that into the logic. So if you're doing a context for evaluation context, where the compiler can see a sequence of operations, they can deduce the fact that built-in unreachable could be called. It might be able to warn. But I would say that the tooling there is those sorts of improvements have been very recent, and they're not entirely reliable yet. They'll get better.
Yeah,
they'll get better.
I've had problems with optionals. In fact, where the compiler has come up with situations where I'm staring at the code, and for the life of me and all my colleagues, we can't see that it can happen, but the thing has said it may be used uninitialized. We're like, no, it really can't. So I don't know if I sort of see your point there about the tooling is not quite there yet. So also
but maybe you're using std optional wrong and you don't know.
I mean, that's totally possible. That is also possible. Yeah. I mean, it's also worth noting that built-in unreachable is sometimes an optimization guide. You can use that as a way to say to the compiler, I know this can't happen and should not happen, and therefore you can assume that it won't. So like saying that I'm prepared to accept undefined behavior if this is not true. So
that certainly is another situation. Yeah, so it doesn't bother compiling in function return semantics, so it'll just trash
things like that. Or I've used it in cases. Sorry, this is a bit off track, but you use this in cases where I can say, like, I know that this particular value is a multiple of 64. So if you're going to do loop unrolling, you can take advantage of this. If I say if I amp 63 __ built-in unreachable, and the compiler goes, oh, I see. I know now that the bottom 4. How many 5 bits are 0. I can just do loops of 64 and unroll, things like that. So
yeah, it's amazing that they can do that. I know it's such a simple optimization technique, but even still, when you look at the assembler that pops out, you kind of go, cool.
I know. Compilers are smart. So yeah, I suppose I take a bit of offense at the fact you're saying like sometimes the optimizer gives up and too early. I'm like, have you seen how hard these guys work to try and make our torturous code compile down to like the 3 instructions it can be?
Well, I think naive users are both amazed at the stupid things the compiler can't do and the incredible things the compiler can do.
Right.
Because machines think different than we do. And so some of the things that you and I would say, well, isn't that obvious? Well, from the compiler's point of view, no, that's not at all obvious. And then things that are like, the compiler could figure that out. It's like, well, yeah, it's pretty straightforward for the compiler.
Oh, absolutely, in a big way, actually. And I have to say that GCC 6 and later and Clang 4.0 and later have got a lot better than they were before in terms of dealing with variant storage. I mean, previously compilers looked at variant storage and just went, I give up pretty quickly. You kind of one of the things that Outcome has an optimization in it is code implementation, which is completely useless now on newer compilers, but it used to work really well back in the day on earlier Clangs and GCCs. So it actually has a common storage type underneath all of the different varieties that might pop out. So if you're using the expected and then you chain it into a result, it'll actually underneath the bonnet, it's exactly the same storage type, which is implementing both. And all you've done is you've implemented the personality on top in terms of API differences. So the compiler will completely fuse that storage and do no actual memory copying or memory moving. And that's even under older compilers. But Clang 4 and GCC 6 are now sufficiently clever that they can spot when the bits in one object are the same as the bits in a second object, and they just completely elide any form of memory copying or moving. So that's a new optimization that's turned up in recent compilers and has eliminated some of the complexity that I have in Outcome, which then of course gets me in trouble during review because people say, why you have these weird nested class implementations underneath here and you're all funneling down to a common implementation. And you're like, well, there's no real reason now apart from being 2-year-old code base. It used to be important.
So I have a question. I don't want to cut you off, Matt, if there was other stuff you wanted to talk about. Or
no, I was going to say, Jonathan wanted to say something, I think, so I was going to like defer to him.
Yeah, I wanted to make a joke earlier, but that moment's past now. And
oh, I'm sorry.
I wanted to say one last thing about Outcome. So during the review, there were discussion about dropping the formal empty state, and then what should the default constructor do, and discussion about that. And someone suggested, well, let the default constructor do nothing and leave it in an initialized partial form state. And I was reading that and thinking, but then the Outcome still has the empty states. It's just now undefined behavior to use it instead of defined behavior. And this was exactly what my CPP Now talk was about. It was about using the type system to your advantage. And if you have an undefined behavior state that you could simply make unrepresentable by deleting the default constructor, just do it. You save time debugging.
Yes, people have raised that exact idea of just having uninitialized bytes with no way of knowing whether they're uninitialized or not. As I indicated afterwards, I don't think much of that idea. Not least for the fact that not in expected, but in terms of outcome and result, I deliberately use a code idiom which ensures that both success and failure are equally penalized in terms of branch misprediction. So, and I have a deliberate fake empty state, even in the case where there is no empty state, to force the 20 cycle branch misprediction. And people are like, what do you mean? You're not choosing success over failure? And I'm like, no, predictable latency is more important than minimum latency for one of the code paths. So that's a design choice. And I mean, that's a weird sort of thing. You're getting down to 20 CPU cycles and, you're making design decisions based on having those or not. And 20 CPU cycles is so little. It's such a tiny amount of time. I know when you add them all up, if you do a few million of them, it might turn into actual time. But
just because we're touching on a subject that I actually feel I can contribute to for a change, as opposed to all these highfalutin like C++ type things, I have recently been embarking on a bunch of branch predictor related sort of research, and the branch predictors nowadays in CPUs are nothing short of clairvoyant. So I have slowly but surely started backing out some of my non-branching code to be more branch-based, because I've just found that the compiler, the CPU will get it right. So I would suggest, like, at least bearing that in mind in any kind of mental model you might have built up of how branch prediction works. I agree that when it gets it wrong, it's still like 20 cycles, but it very, very rarely gets it wrong nowadays, even with like seemingly unpredictable sequences.
Surely only in a loop.
You mean like, well, if you're in a, I mean, if you look at how they're implemented in terms of the ones, 6 or 7 years ago now, even 6 or 7 years ago, they were using branch history tables. They were looking at like the sequences of branches that led to a particular branch happening and whether they were previously taken or not taken, hashed into a bucket that would then learn that. I noticed that in the 15th iteration of this loop, when this other loop was true, sorry, this other condition was true, this thing is always taken. And so it's smart. Smarter than you might just think naively. So loops work very well, but so does complicated control flow.
Huh. I have to admit, I've always worked on the assumption that if it's branching to a later address, the branch predictor will assume it won't be taken. And if it's branching to an earlier address, then it assumes it will. And I'm getting that purely off the ARM6. So that's
right. Yeah, I think you might share a common ancestry in terms of our CPU experiences. So yeah, that's my thought too. But nowadays, the fetcher is on the x86. The fetcher is so many pipeline stages ahead of even the decoder to determine that there is a branch in the 32 bytes is fetched, that it's already had to make the prediction that in this block of instructions there exists a branch which is likely to be taken, and therefore the next fetch is going to take the address from there. And it's only 3 or 4 clock cycles later that the branch is even decoded. So the idea that it could follow the branch before it's even decoded it is that ship sailed. So that's another reason why you can't put like little hints on the instruction to say, hey, I think this one's taken, or assumes taken, assumes not taken. Those went away with the Pentium 2. Or Pentium 5.
Sure. It's like virtual function overhead is nil on any modern CPU. But if you do a double function, so in other words, a virtual function that calls a virtual function, that's still a penalty. Right.
That's one of my favorites actually, and I think I would like to put together something for this, because my poster child for this stuff used to be like, hey, you would never write an interface that has like set pixel that's virtual, because that would be dumb. There would be nothing that you could every single thing would be too expensive to like write every pixel to the screen or whatever. But as you say, it's really, really cheap now to call a virtual method. But what you've left on the table is the fact that the compiler can't make any guesses about what the heck is the other side of that virtual function call. And so even with like link time optimization and stuff, if there are multiple types available that can implement that interface, the compiler has to be pessimistic and call and assume that everything's going to be thrown away and no state can be kept and there's no opportunity for inlining, all that kind of stuff. So I think that's kind of the fallacy in my own mind now that people have about virtual functions. Oh, it's cheap now because the CPUs are really, really swift. Yeah, but you're throwing away the optimizer's ability to do a good job around the call site.
It's kind of like, I think people have the wrong idea about why inlining is advantageous. They think, well, right, you get rid of the function call overhead. You don't have to create the new stack frame, all that kind of stuff. But that's not the real key.
Mm-hmm.
The real key is that the compiler has to assume worst case about what your code is doing if it's not inline, right? So if it's about to load something, it has to assume the function call right before it changed the value of whatever you're trying to load,
right,
or whatever, right?
And
but
any kind of sort of
it's not that it can see what it does; it can see what it doesn't do.
Right, exactly.
So it doesn't have to make these worst case assumptions. Yeah, this is one of the things I cover a lot in training to explain to people why inline is so valuable, because I don't think people have the right idea about it.
I was having a Twitter conversation with someone about optimizing, and they were surprised that -02 and -OS still did tons of inlining. And like, yeah, inlining is a fundamental ability to be able to pull all the code in, not to bloat the code size, but because often the compiler can net everything out and go, oh, I see, it just returned 7. All right, we'll put 7 here, and not all these convoluted stuff. And of course, we love our abstractions. They make it easier to write software. It makes it maintainable. It makes it testable. But ultimately, as we wouldn't be writing in C++ if we didn't care about the fact that we can do all this, and yet the compiler's just going to do more VAX, 7 or LDR. R0, 13 or R13 or whatever.
So we kind of need to think about winding down here. I don't want to overstay our welcome.
I want to.
Yeah, go ahead. Did you?
Yeah, one thing. So John, you agreed to the things I said previously about the default constructor?
Are you asking?
Yeah, I'm asking you.
You asking me?
Yeah, you agreed to not having the default constructor if there's no state to.
I didn't think I weighed in on that. I thought that you and Niall were talking about that.
Oh, okay, but I just because the logical conclusion of if you don't want a state, make it unrepresentable, and don't add the default constructor is our moved from state discussion we had the entire summer. So I was just. I was misinterpreting some of your reaction.
I kind of like the concept of regular types, and a regular type requires a default constructor. And so when you start to say, no, you can't have a default constructor, I start to say, well, it's not a regular type. Now it starts to get to be, you have to think about it a lot in terms of things like, oh, well, if it doesn't have a default constructor, then I can't put it as the payload on a map, for example, because I might want to use the index operation, and that requires. Right. So, I'm not sure I'm buying on this in the general case. Now, there may be situations where you can say, no, this is essentially RAII in the sense that if it can't get what it needs, then it shouldn't exist. And so,
I was thinking you agreed there. I was misinterpreting you, and then wanted to point out that you can't take the logical step without disregarding everything you said all summer.
Well, I'm not as sleep deprived as Niall is, so I'm not going to step into that one. One of the things that I wanted to ask about, Niall, that you've said you've made some, I don't want to say compromises, but what you meant was that you've been swayed by the opinion of the reviewers. So what does that mean as far as someone looking at the library now? Because you've said, well, this is probably a change. Obviously, you haven't implemented that change yet. So if I wanted to go and look at the library now and make a comment, how would I know what parts of the library we've kind of already decided are going to change?
Well, that's probably why I can see that the library would get rejected in its current form, is because the design through review, which effectively is what's happened, has so substantially changed the public API of the presented library that it's no longer really representative. So how can you approve such a library if it only represents a fraction of what people have asked for? So I mean, the existing library still is in the current proposal for what it will become. It's just a much smaller part, because what they've done is they've expanded the variety of potential transports. What was it, 8-fold? Wow. So you now have 8 times more, and in fact there's actually an underlying constructor which lets you construct 108 different varieties of these things with all sorts of different semantics, because that's a different combination of all of the things multiplied against one another. But that's what happens with the Boost. You know, you take a very simple idea, you try to submit it, everyone wants it to be slightly different, so you end up implementing them all to make everyone happy, and then you end up with this thing which is exceptionally complicated. And then usually world standards people have to take it, and they have to choose one out of all of those which is suitable for standardization. But that's probably a good thing, actually, because as much as I've been using my particular variant, my formulation for the last few years, and I know it works very well with my code, with my programming style, it doesn't mean that, say, you, John, using it with your programming style, wouldn't find yourself, constantly getting memory corruption and getting very badly bitten and terrible performance. So I think your earlier comments about that this stuff going out and being practiced by thousands of people and being used and getting that from that standard. In other words, standardizing existing practice rather than standardizing what people think ought to be.
Yes.
I think that's very, very important, and I think that's something that WG21 had got a little bit ahead of itself, perhaps, compared against, say, WG14, because I've actually interacted with WG14 in the past. I've never actually been to a WG21 meeting, for example. So it's I think standard practice is much safer for an international engineering standard.
No, and I, as I said, I had some conversations with people at C++ now, and I think there's going to be at least a few individuals. Of course, I didn't talk to 100 people who are on the standards committee, but I think there's a few individuals who are going to be pushing back a lot harder and say, again, it doesn't have to go through Boost, but it has to have a large user base. And just because the library sounds good and it's got a few people who are championing it, that's not the same thing. And so anyway, I guess we need to wind this up. I, again, want to encourage people to check us out next week, and I will, foreshadowing here, I think there are 2 more episodes before my wife and I run off to a fairly long cruise. So we're going to be gone for a few weeks, and we'll miss you all very much. But don't miss next week's show with Howard Hinnett. I want to thank you, Niall, for coming on with really not very much notice, and we'll hope to get you back when we can see your smiling face. And definitely want to talk to you about other things, such as Summer of Code and some other things which we didn't have time to get to today. and very, very glad to have you on, Matt, and looking forward to hearing about your plans with attending some C++ conferences.
Finally.
Finally. And always nice to have you on, Jonathan, even if you're trying to trip me up. So, Matt, sorry, Niall, we have a tradition that we close the show by wishing everybody safe coding. So I think the time for us to do that is now. So thank you all for tuning in. We hope to see you again. And until then, safe coding.
Safe coding.
Safe coding.
All right. Thank you all very much.